Hey, welcome back everybody. Thanks for watching. We've got another neat linear algebra problem for you. So if A is the following matrix, the matrix with 0 minus tangent of theta over 2, tangent of theta over 2, and 0. And we've got that this product, which is the 2 by 2 identity plus A, times the inverse of the 2 by 2 identity minus A, is equal to the matrix A minus B, BA. Then we want to compute 24 times the quantity A squared plus B squared. We're going to need some tools, but before we mention the tools, I hope that your eye is drawn to this. We've used this Weierstrass substitution quite a bit on the channel, and so instantly when I saw the problem, my eye was drawn to that. So we're going to need the following. So for sure, we're going to use a Weierstrass substitution. We're going to need classic matrix multiplication and the formula for a 2 by 2 matrix inverse. Okay, so let's go for it. Okay, so we've got some computing we want to do. Let's find this, 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 and then this. Okay, so first, let's let x equal tangent of theta over 2. And so we can write a like this now. So it looks like 0 minus x, x, 0. And so with that said, let's find this. Okay, so the 2 by 2 identity plus a, that's exactly 1, 0, 0, 1 plus 0 minus x, x, 0. And so we just add component-wise. So we've got 1 minus x, x, 1. Okay, so now let's find this. So 2, we need the 2 by 2 identity, minus a. And yeah, we just subtract component-wise. Okay, so we got 1 minus 0, 0 minus minus x, 0 minus x, and 1 minus 0. Okay, that seems pretty good. Let's go ahead and find the inverse of that. Okay, so we're going to use the formula. So I need 1 over the determinant. So this will be 1 over. And so product minus product gives me 1 plus x squared. These they'll switch positions, but since they're 1, it's the same. And then these two will they will negate. They'll negate. Okay, so that seems fine. So now we want to look at this product. And so, should I call it 4? Let's call it 4, why not? So we've got I2 plus A times I2 minus A quantity inverse. That's equal to, well, this sort of scale factor, we can bring that in front and deal with that at the end. That's perfectly fine. Nice property of matrices. Okay, so got this here, got this here. Okay, so let's see what we have here. Okay, so upper left entry, so just row by column. So this will be, looks like 1 minus x squared. Say the upper right entry. So let's see, what do we have here? So we've got product plus product. That looks like minus 2x. Okay, lower left entry. So this will be, this looks like x plus x. That looks like a 2x. And the lower right entry, that looks like negative x squared plus 1, or 1 minus x squared. Okay. And we're setting that equal to a minus b, ba. So now we just need to sort of focus on this. Okay, let's focus on that. Okay, so distributing this gives me the following. So I've got looks like 1 minus x squared over 1 plus x squared. And then I've got this 2x over 1 plus x squared minus 2x over 1 plus x squared. And then I've got 1 minus x squared over 1 plus x squared. That's a minus b, ba. But if we think about our Weierstrass substitution, well, this reminds us of cosine. And, well, this reminds us of sine of theta, right? So going with our Weierstrass substitution, that's the same thing as cosine of theta minus sine of theta, cosine of theta, and that's equal to a minus b, ba. And so from this, that means that, so think about determinant, cosine squared of theta plus sine squared of theta should equal a squared plus b squared. But that's the classic Pythagorean identity 1. So 1 is equal to a squared plus b squared. And so 24 times a squared plus b squared is 24 times 1, which is 24. So neat problem. It all hinged on recognizing the Weierstrass substitution, right? It looks very, very difficult at first, but if you're familiar with such substitutions, it's not bad at all. It's really not. The computation was very straightforward. That's the tricky part. So knowing such tools is very nice. Very, very nice.